Hi everyone. Let's take a look at some long division and synthetic division as it turns out. Let's do this one by long division first, and then I'll show you a little trick here. X to the fourth plus 3x cubed minus 5x plus 4. We're going to divide that by x plus 1. So my divisor, x plus 1, I'll put in here. And in my dividend, I've got my x to the fourth, my 3x cubed, my minus 5x, and then a plus 4. And if you've watched my other video on long division, you will have seen that I like to put in little ghost x's if I need to. In this case, a ghost x squared, because they need to have descending orders of power, right? Fourth, third, squared, first, and then constant term. All right, so I'm going to go a little quicker on this long division problem. X goes into x to the fourth, x cubed times, right? X cubed times x is x to the fourth. X cubed times 1 is just x cubed, right? And so you get to this setup right here. And then you've got to remember to subtract. You take this guy here and change both signs. This sign right here, right there, it's got to change. Hey, if the Mr. Hyde thing works, then by golly, I'm going to keep doing it, right? So let's see. The x to the fourth term drops out. 3x to the third minus x cubed is 2x squared, or excuse me, 2x cubed. Now I'm going to bring down my 0x squared here. And since I'm dividing by a binomial, I want to keep running with a binomial down here. So I'm going to have a plus 0x squared right there. All right. X times what gives me 2x cubed? Well, x times 2x squared, right? So 2x squared times x is my 2x cubed. 2x squared times 1 is my 2x squared there. All right, so I'm going to be subtracting that. So don't forget, you got to change both signs, okay? Not just the one, both signs. Both signs. This sign and this sign. Right there. Right. So then we change that, and then we're going to have 2x cubed minus 2x cubed, that drops out. 0x squared minus negative 2, or excuse me, minus a 2x squared there gives me a negative 2x squared. So that's, again, a reason why I like to have that ghost x squared there. Had you not had that there, the tendency might have been to accidentally put the negative 5x right there and try to go negative 5 minus 2 to get something that's totally wrong. All right, so you need to have like powers subtracting each other or adding each other because they're like terms. All right, negative 5x and 2x squared, they're not like terms. All right, let's keep going. Let's see, I brought down the x squared term. I need to go after, let's get color consistent here, my negative 5x now. Okay. Colors. So, x times what is a negative 2x squared? Well, a negative 2x. Negative 2x times x is a negative 2x squared. Negative 2x times 1 is a negative 2x there, right? So once again, we got to change our signs because we're going to be subtracting. And subtracting is the same thing as taking the opposite, right? Which means change the sign. Change the sign. So this sign changes, and this sign changes. Right there. Yeah, it's a negative, so it's got to be a plus. It's got to be a plus. Got to be a plus. Woo! Thank you, Mr. Hyde. Yes, it needs to be a plus. If it's basically, if it's positive, go negative. If it's negative, go positive, right? All right. X squared term drops out. Negative 5x plus 2x is a negative 3x. And then finally, we'll bring down my plus 4. So x times what gives me a negative 3x? Well, negative 3, right? Negative 3 times x is a negative 3x. Negative 3 times a positive 1 is a negative 3. Right? So we're at this point. So again, we're going to be subtracting. So which means you got to change both sides. Both sides! Both sides! Yeah! Change this one! Change this one! Make sure to change this one! Yeah! Absolutely, yes, you got to change that one as well. So, negative 3x plus 3x drops out. 4 plus 3, right? That's not minus 3, it's plus 3, is going to be a 7. And that's the remainder. So we're going to write this as plus the remainder of 7 over the divisor, which was x plus 1. Okay, so that problem is now done. But is there a better way? Can we do this a different way? The answer is yes. This video is getting kind of long already, so I'm going to go ahead and shut this one down and then do another one, the exact same problem, a different way. Okay?